Let us see how can we geometrically prove a minus b the whole square is equal to a square plus b square minus 2 times a, the product of a and b. For that, let us consider first the value for a as 12 units, okay, and the value for b as let us say 5 units. So what initially you have to do is, for proving it geometrically, you need to consider a as 12 units, as I told you, okay. So let me take the value of a as 12 units. Fine. Here also I am going to draw 12 units. Here as well 12 units. And finally the last side of the square a minus b, 12 units. So we have taken this side as a, right? So from that 12 we are trying to find out a minus b. That means 12 minus 5, that 7 should remain, and in that one you will be considering b as only 5. So can you see here, this is 5, right? So I will make a mark here. This is b, right? So if the total is a, if this is going to be b, can you tell me what about this portion? That is nothing but a minus b, correct. Out of the whole a, you have removed b, so the remaining will be a minus b. Similarly, all the four sides you need to consider b as 5. So here also b5. So I will be making a mark here b5, and the remaining portion will be obviously a minus b. This side, after marking b as 5, the remaining will be, this will be b and this will be a minus b. Same here. This will be b and the remaining will be a minus b. So this is b and this is a minus b. Now the next step should be, wherever you have marked for b, just let us join the dots together. So this is one line, and perpendicular to that line we will be drawing another line here. Just make two perpendiculars, right? Now you can see here two squares obviously and two rectangles. So if the first one, if you are going to consider as a square, can you tell me what will be the area? That is going to be b cross b, right? And let me consider this as a second part. In this one you can see a minus b as the sides, means that is going to be a minus b the whole square. Now this is obviously a rectangle. One part is a minus b and the other part is b. So the product will be b cross a minus b. That is the third part. And here let me take the fourth part. You can see b and a minus b. So that is another b cross a minus b. Now our task here is to prove the identity a minus b the whole square is nothing but a square plus b square minus 2ab. That is what we are trying to prove here, right? For that, now after completing this, all these particular procedure, that means you have got four pieces here, two squares you can very clearly see, and other two parts are two rectangles, the third portion and the fourth portion. But we know that the area of the entire figure is nothing but a square, right? That entire figure a square means this portion we have taken a as a 12 centimeter, this one we have taken 12, and we know it is a square with the area a square. That entire a square we have divided into 4 equal parts. That means a square, area a square, and the areas of the sum of all these 4 parts also should be equal, isn't it? And finally, when you simplify that, we should get the identity. That is what we are going to prove now. Okay, so we can write area a square is nothing but the sum of all these 4 pieces, right? The first piece is b into b is nothing but b square. Second piece is nothing but a minus b the whole square. Third and fourth pieces, I have 2 times b multiplied by a minus b. So what I am going to write is plus 2b a minus b. I think it's clear for you. Now, a square is equal to b square plus a minus b the whole square plus 2b multiplied by a will be 2 times ab. 2b multiplied by minus b will be minus 2 times b square. Now, I just want to do a little bit of arrangement here and there so that we should arrive finally at the identity. So, I am going to retain a minus b the whole square there itself. So, a minus b the whole square is equal to, I am going to transpose the remaining parts into the left side. That means a square already existing, b square is going to be minus b square, 2ab will be minus 2ab, and this minus 2b square will become plus 2b square. So again simplifying, a minus b the whole square is equal to, we have only one a square to simplify like term, a square minus 1b square plus 2b square. These are two like terms which we can simplify. So while adding you are going to get plus b square. Then the remaining term is minus 2ab. So we have arrived at the identity. The area of a minus b the whole square is nothing but the sum of the areas of a square, b square and 2ab. So we got it now. So area a square, whatever values we have chosen, that means an identity is nothing but it is a true for all values of the variables both on the left hand side and on the right hand side. You can use this with and if you want we can apply this a and b values and let us check for that. Okay, take the left hand side first. That is a value we have chosen 12 and b value we have chosen 5, right? So 12 minus 5 the whole square is nothing but 12 minus 5 is 7. 7 square is nothing but 49 square units. That is a minus b the whole square value. Now let us take right hand side for simplification. Right hand side simplification becomes a square will be 12 square 144 plus b square is nothing but 25 minus 2 times what? 12 multiplied by 5, which is going to be 144 plus 25 is nothing but 169 minus 12 into 5 60, 60 multiplied by 2 is going to be 120. So what is the final value? We have here 49 square units. That means left hand side and right hand side both are equal. LHS is equal to RHS. The identity we have proved geometrically. I hope it's clear for you.